Hello, people. This is Teacher Calvin, and welcome to another episode of Science I Can Do. And with our great tips, I'm sure science you can do too. Today, you're going to be watching a video conferencing lesson on the topic of energy and interaction of forces. So sit back, relax, and enjoy the lesson.
Okay, hello people. We are trying to attempt a MCQ question 28 from Raffles Girls Primary School, preliminary exam 2020. There seems to be a bit of uncertainty for many students because they are not sure how to get the answer for this question. Okay, in this video, we shall attempt to explain to you how we could derive the answer. All right, here we go. It says, uh, Trina conducted an experiment using spring X and Y. She hung different number of weights, one at a time, and recorded the length of the springs. Her results were shown in the graph below. Well, as you can see, spring X, let me put it in red color, will stretch. Well, spring X looks like it stretched more than spring Y. Okay, as you can see, for the same number of weight, for example, for a 100-gram load, you can see that spring Y only stretched 70 cm, whereas for 100-gram load, spring X would be around 100 cm. Yep. So just approximately. So it seems that string X is like a more flimsy kind, easily stretchable, whereas spring Y is the tougher guy, which is hardly stretchable. Okay. Spring Y is, for example, for those who are not sure, you can find spring Y maybe in this playground where you have like this kind of seesaw, and spring Y would be like a tough kind of spring that was attached to the seesaw where you can rock and rock and rock and rock, and it wouldn't move much. Yes, but spring X would be those flimsy kind of spring where they can easily stretch with a slight load, whereas this would be those like thick kind of spring where you don't stretch them much because they are stiffer, they don't stretch so much. Good. Now, what can we see? The two springs X and Y were used to make the two dish rack, each which hold identical number of plates. Now, look at the question carefully. Where is the spring? Well, for this dish rack one, this is the spring. Yeah, these are two springs here, and they're holding up the metal disc. Of course, naturally, when you put the same number of plates, this one will go down more because this spring was stretched by the weight of the plates, and since they are flimsy, they are quite stretchable and they end up lower. You can see that? Lower position. This metal disc is at a lower position. Well, compared to this, let me show you in blue color. This is the stiffer spring and it's holding the same number of plates because it doesn't stretch much. You can see its position from the base level is higher than dish rack 1. Dish rack 2, this metal disc. Please take note, this metal disc here, and the metal disc here, this you can see is lower, whereas this is higher. Why? Because the spring Y doesn't get stretched as much even though they hold the same number of plates. Right, now let's continue to read. When Trina removed 3 plates from the top of dish rack 1, the metal disc moved up from P to Q. She also removed 3 plates from dish rack 2. Well, why did the metal disc move up? Well, the metal disc moved up because the spring was exerting a pull-up force onto the metal disc because it tried to get back to its original position, right? Because it was stretched. So if you reduce the weight, they will try to pull up so that they can restore the original length of the spring. Because of the weight of the plate is pulling down, they are like acting opposite forces. The weight of the plate is down, right, pulling down, whereas the spring is trying to restore its original length by pulling up. Okay, so you must know the mechanism and how it works. And the plates are just supported by a metal disc. Now let's evaluate what are the options for the answer. Based on the graph and the information provided, which of the following statements is or are true when the 3 plates were removed from the 2 dish rack? Number 1, A. It says the metal discs on both racks have gravitational potential energy. But we're talking about this green color metal disc here. Yes, both of them are raised above the ground and they have gravitational potential energy because they are above the ground level or base level. However, the metal disc, which is mentioned here, it's not possible to have elastic potential energy. Why? Because they are not a spring. They're just a metal disc supporting the dish. So number A is out because it cannot, the metal disc is not a spring and hence it does not have elastic potential energy. So A is out. As for B, the metal disc on dish rack 1 will have less gravitational potential energy than the metal disc on dish rack 2. Well, you look at this metal disc on this green metal disc here. This green metal disc is much lower to the ground level compared to the metal disc A, which is much higher. Yes, this metal disc is much lower. Of course, naturally, in that case, dish rack 2, the metal disc, since it's higher above the base level, it will have more gravitational potential energy than dish rack 1. So it says metal disc on dish rack 1 will have less gravitational potential energy than metal disc on dish rack 2, which is correct. Why? Because dish rack 2 is higher. The higher you are, the more gravitational potential energy you have. Look at this. This dish rack 1 is at the lower position, whereas dish rack 2 is from here to here, which is higher above. So this statement is correct. Okay, option C, the metal discs of both racks moved up because of the stretch string exerted a pulling force on the metal disc, which is correct. Why? I've explained earlier that the metal disc pulled up because they try to restore their original size of the spring. Because they were stretched, springs always try to return to their original length. So in this case, it's true. The metal disc for both racks moved up because the stretch string exerted a pulling force on the metal disc. The reason for the disc to move up is because the spring tried to restore the original length. So when the plates are removed, there's less weight. Hence, the spring will try to restore its original length by pulling up. Okay, hence the metal disc moved up. Okay, so C is correct. D, the metal disc moved up as the weight of the blade is greater than the elastic spring force acting on the metal disc. This is not true. Why? Because if he says the weight of the plate is greater than the elastic spring force. Well, if the weight is greater, which is the downward force, which is greater than the spring force, it can never move up. It should move down. So this is false. Okay, I repeat, the weight is greater, it will be going down. It cannot be going up. So this is not correct. So the possible true statement should be B and C. B and C is option 3. So the answer should be number 3. Hope this helped you in your PSLE, and good luck, everyone.
Thanks for watching, and if you like what you see, do give us a thumbs up, share, and subscribe. And for more great tips like this, be sure to watch Science I Can Do.